As you've heard, my background is fly ash, and in that area particularly logistics. And international logistics are a challenge, very interesting, but I'll come to that a bit later. Our parent company, the STEAG GmbH in Germany, as you might remember from my colleague Matthäus yesterday, is also an operator of coal-fired and biomass power stations, wood-fired power stations in particular. So we operate about 12,000 megawatts of capacity ourselves. STEAG is 100% daughter company, parent company of ours, and we are a group of companies, but I'll come to that on the next slide. So who are we? In particular, the STEAG Power Minerals Group, and as you can see, our history goes not just back to 2002. This company is now over 30 years old, and as you can see, there are a few key figures on the top bit of this slide, just showing that we have about 150 people dealing with coal combustion byproducts and industrial byproducts from other industrial combustion processes. But mainly our core business is byproducts from coal-fired power stations. And as you can see in this frame bit below, it's actually a group of companies. We have 6 subsidiaries in Germany. Parts of some of those companies are regional companies. Some of those companies are dealing with are specialized to deal with a particular product. For example, Mineral Plus solely deals with byproducts generated from industrial processes, whereas our specialty is to deal with byproducts from coal. Euroment is our daughter company in the Benelux area. Power Minerals, represented by Peter, is our daughter in the United Kingdom. In Eastern Europe, in Poland, we've got Energo Mineral, and BPU is a company in the Czech Republic. But we're also trying to grow in and outside of Europe. But this presentation today is about the developments of coal combustion. I mean, it goes without saying that fly ash is usually, or rather solely, dependent on the development of coal combustion. If there's no coal burned in the boilers, we have no ash. So what's the future in this? And well, I had, in the run-up to this conference, I had the cheek to put in a remark about the England football team in my presentation summary. I didn't know that Rob would actually print that. I said the future of coal is as difficult to predict as England's performance in the European Cup finals. And Rob replied quite right. He said, "We shall see. Let's just hope it doesn't go to penalties." Anyway, the reason I said that is, with coal, I'm not sure about England, I really can't judge this. With coal, it's going to last much longer than some people think, and than some magazines report. The main reason for that is the reserves of coal on this planet, and this is a statistic from a reputable source. It's not something we've drawn up. So as you can see, the lifespan, so to speak, of coal is much longer than any of the other resources. And if you balance that against the world electricity demand forecast, you can see that there is an ever-growing demand versus the lifespan of those resources. So I think right now we're hit as fly ash recyclers. We're hit by developments such as the co-combustion of biomass, and and the very unstable utilization of the coal-fired power stations. But like Charles Daniel yesterday reported very eloquently about the major trends in cement, and that gave me some relief, because right now it looks as if it's going down forever. I think here we have a similarity to those trends. There is a dent in the utilization of coal-fired power stations, but I think the general trend is that it will increase. Of course, you have to look at, same as with cement, you have to look at each region in particular. It will be different between Europe, Asia, other regions, of course, but the general trend is that we will see coal combustion for a long time, I believe. So what do we have, and now the focus is a bit more on Europe. What do we have in terms of technology? And I believe the recent past, the last 3 years, have been very interesting for those of us who are related to companies operating coal-fired power stations. This is the technology, and this slide is from a power station. From a presentation which goes back a couple of years. I mean, it's still, what's on there is still perfectly accurate. We have fine grinding of coal. We have DeNOx devices, supercritical boilers. The steam parameters lead to a much higher efficiency. Is anyone in the room who can explain an optimized cold end of a steam turbine? In that case, you can. Thanks. In case of any questions,
it's a condenser.
In case of any questions, please ask him.
If you have seawater, there's a low temperature, and the efficiency of a power plant is dependent on the lower the temperature of the cooling water, that's the higher the efficiency. So if you need a cooling tower, efficiency is always worse than when you have a power plant at the seaside which uses fresh seawater, like in Denmark. So in Denmark you see always efficiencies higher than power plants in Germany with the cooling tower. That's optimized cold end.
Thanks very much. In case of I'd go out very an expert. I'm not. Although the other point.
Cold end produces no flyers.
That's right. That's right. So we have efficiencies of like 47% and above. But I could nowadays add, if only this technology would work, because as I think almost everybody knows, we have technical problems with the metal used in these boilers. The metal does not, or in real life, in the operation of a power station, does not withstand the pressures, or here is a technical term, we're suffering from hydrogen corrosion in those, especially where the parts are welded together. The welding does not withstand those pressures, and the hydrogen corrosion leads to, it forms holes, and of course that's a major problem for us. We're right now replacing parts of the boiler houses, so subsequently we have, with our power station, we have a delay of 2 years, in excess of 2 years. But we're sitting in the same boat with other companies like Vattenfall, E.ON, RWE. Pretty much everybody suffers from the same problem. So that has led to another delay of potential new fly ash volumes, and of course electricity available. But in more generally, that is a specific problem which I'm sure we will overcome over the next 2 years. But there is another thing which will drive the coal requirements, and I would like to point out that there is actually a dilemma in this. The new power stations are clean coal technology power stations with efficiencies up to 47%. But the trend, or say the public opinion, drives us to research carbon capture sequestration power stations, which will hopefully one fine day lead to CO2-free power plants. And within carbon capture, the research and development is specifically with integrated gasification, IGCC. The CC stands for combined cycle. The produced gas goes into a combined cycle turbine. Oxyfuel, which basically means burning the fuel with pure oxygen rather than air. The purer the flue gas is, the easier is the CO2 sequestration. Post-combustion measures are what's being researched, for example, in Denmark in this pilot plant. Pretty much every existing power plant is CCS ready, so to speak, but that would be with post-combustion measures, whereas the top two measures would be part of the whole building process. What is the dilemma? The dilemma is basically that with clean coal technology of today and of tomorrow, there is a CO2 reduction simply because the efficiency goes up. So with every ton of coal we produce more electricity and less CO2 per megawatt hour. But then, as you can see, there would be a spike in coal requirements, in coal demands, if we change those power stations to carbon capture, because all of a sudden the efficiency would go down, and figures are mentioned that the gap between the clean coal technology and a CCS power station would be 25% in efficiency. So all of a sudden we are down at 23-25% efficiency. So all of a sudden we would need an awful lot of coal to produce the same amount of electricity. And that dilemma, I'm not quite sure where this is going to get us, but it's something which is on the doorstep, which I think is going to happen, say, 5 to 10 years down the line. But again, having seen what happened after the Fukushima disaster in Japan, which has changed the world quite dramatically, I think our guess is as good as anyone else's in terms of what's going to happen to the energy industry, to the coal industry as a whole. The world, Charles said yesterday, the world is changing very, very quickly, and I couldn't agree more. It has changed very quickly in the last 5 years, and it will keep changing. So basically, what's the impact on byproducts? The characteristics of byproducts are, of course, influenced by the fuel, the chemical composition, the color, in some cases of very little importance, in some cases of major importance, but the process also influences the quality in terms of grain size, residual carbon, and the content of amorphous glass. The quantity, that I think is pretty basic, goes with the installed capacity, with the ash content of the coal, and with the operating hours. As easy or as simple as that might sound, it is simple. The operating hours are our biggest headache right now, because something which was not really mentioned on the previous slides, where it was about the general energy demands, is the European system of prioritization between the various generators. So in Europe, I think everybody knows this, renewable energy always comes first against fossil fuels, nuclear, everything else. And nuclear power in Germany and lignite power is baseload. The renewable power jumps up and down, with the sun and the wind. I mean, who would have thought our weather is as bad as England's? Who would have thought that solar power in Germany would ever play a role? But it does. We have something like 16,000 megawatt installed in solar power. And in those few sunny hours we have, all of a sudden we have the equivalent of 16 power stations coming onto the grid and given priority over everything else. So the buffer in between lignite and nuclear and the renewables, the buffer in between is gas and coal. So right now we have more than 200 startups and shutdowns every year. It's a nightmare for our engineers. It just, in terms of maintenance and everything else, it's very, very difficult. And so the operating hours, although it might sound daft to mention it, it's one of our biggest headaches. We have between 2,000 and 7,500 hours per year. It's very, very difficult to predict. However, I think it's worth mentioning that we have many new build projects going in Europe, specifically I would say in Germany and the Benelux region. And the major change is that these new power stations are replacing old power stations, and subsequently from a variable fly ash quality we will develop to a more stable fly ash quality. So I won't go into much detail. We've talked about the quality of fly ash a bit yesterday, and I won't bore you with these details, but I think that the bottom line is we will see with the new power stations more consistent quality, low in LOI, very fine, and as we've heard yesterday, the finer the fly ash is, the better the reactivity. So that's it. That is, after all, good news. Again, we've talked about this to some extent yesterday. The figures about the overall production in Europe do vary. That is mainly because, and I think Lyndon's here, who is with us today, can confirm that the figures from Eastern Europe are not very reliable. So it varies from something like 40 million tons to 60 million tons per annum. One thing worth mentioning is this also includes fluidized bed ashes, which are not very good for cement, or can only be used in very small quantities. But other than that, as you can see, the major product from coal combustion is fly ash, and this is what this is mainly about. I'm very glad this has been mentioned in various presentations yesterday, so I won't go into much detail with this. The one thing I would like to say is that in cement or in cementitious applications, most of the fly ash is used here in Europe, but again that depends hugely on the quality. So if it's in Europe, we have the EN 450 standard, which regulates the use of fly ash in concrete. If the ash matches the requirements, it's easy to use. And actually, as of today, we have a lack of supply. Whereas, had you asked me 3 years ago what would be the supply situation in 2012, I think I would have said, and I had this discussion with Art Courthout yesterday, I would have said there will be plenty of fly ash. Don't worry about it. We'll have enough. Actually, we have an undersupply. We're short of fly ash as of today. And that's why we've started, cross-border transportation of fly ash, just to even out the supply and demand situation. What's the outlook? We are looking at, and again, that has been a subject of yesterday's discussions. We're looking at high volume fly ash concretes. Right now the standard regulates a maximum of 35%, but we're looking at chemical additives, agents, superplasticizers. The norms are looking at higher volumes of fly ash. So there's a lot of interesting research going on in that area. The activation of fly ash, and I was very pleased to hear that things like metakaolin, which wasn't, to be honest, really on my radar screen, can improve the early strength development in concrete quite significantly. And then applications like acid resistance or sulfate resistant concretes, we've had that also yesterday. Then the utilization of low-grade fly ashes, that basically means fly ash beneficiation. We have STI here today. We are doing some research with a process. We're actually operating a fly ash beneficiation process at Rugeley Power Station here in the UK, and alternative concepts for binders. So that's where our engineers are looking at right now. And I've mentioned that already. These arrows on the picture on the right hand side, and as you will see, 2 slides before there was mention of 60 million tons of fly ash produced in Europe. This production figure, 27 million euros, that means fly ash from dry boiler combustion, usable for concrete. So it's not actually a different figure, it's just part of the overall figure. And as I already said, there is a mismatch between those areas where there is an overproduction of fly ash and where we have an undersupply. Those arrows we've drawn into that map are actually arrows where fly ash is going from one place to another. In the middle there is an impact of a newly constructed. There is a number of arrows in the north of Germany. That is Hamburg-Moorburg Power Station, where we will see fly ash going to various places. This has not yet started, but all the other arrows, that is already happening, and that is just what STEAG does. There are other companies doing cross-border transportation, so as you can see, a lot of fly ash is already hitting the water and going cross-border. So basically, the message of my presentation is the volumes of fly ash are very, very difficult to predict, and we are already living in a time where the power stations go up and down like anyone's business, and the problem or the challenge we're faced with is, do we have the logistics to answer those questions and to meet those challenges? So fly ash, and we had that briefly yesterday, it's not such a high value product that it could bear any transportation costs. We can't bring fly ash, say, from South Africa or India into the Mediterranean or the European area. The logistics are simply way too expensive to do that. So we have to look at this scenario on a European level, and the major drivers for the costs are storage capacity and the load and discharge facilities. So we have to really keep those costs in check to make it possible to go cross-border. But that is our major challenge. So all of a sudden, from a local to a European business, that is the growth path behind us. Logistics have grown incredibly in importance, and that is where we probably do most of our work right now. And then, well, again, quality-wise, that is the good news. It's going to improve. Logistics are very, very difficult, but still we have quite a significant volume of fly ash which is not suitable for those high-value applications. So beneficiation will play its part in coming years. So actually, as I said, to come back to England's performance at the European Cup finals, I don't know what the future is. I hate to say that in front of a YouTube camera, but as a matter of fact, it's very, very difficult to say. Logistics will be our major challenge, and we hope to keep our customers happy. We do a lot for that. So thanks very much.
Thank you very much indeed, Thomas. As we expected, a very interesting presentation. Thank you. Are there any questions from the floor? Please.
Yes, are there any investigations of any influence from this carbon capture storage with oxy-fuel and gasification on the properties of the fly ash?
The properties of gasified fly ash, perhaps Akkoordhout is in a better position with the Boegenum power station to answer that. It is, from what we know, the fly ash is going to be very, very low in density, very fine, and but in essence the answer is we don't really know what fly ash from integrated gasification is going to look like. If that is a likely outcome of that research, I'm not sure. But the oxyfuel fly ash actually is very similar to the fly ash we have today. And I think oxyfuel is, at least from what we know, more likely to become reality.
Any other questions? With optimised logistics, do you see any possibility of intra-regional transportation of coal ash? For example, from India, and I know they have hundreds of millions of tonnes sitting around over there.
They do, and fly ash from India, for example, goes to the Gulf region. In the Gulf region, as we know from Qatar, Oman, Bahrain, there's a huge demand for fly ash cements. In those areas, fly ash actually yields a higher value because of its impact on the hydration temperature. So in those areas, fly ash is worth twice as much as it is in Europe. However, fly ash is being transported to the Gulf region and to East Africa, and from what we hear also to areas like Hong Kong. Not yet to Europe. We are transporting fly ash from the Mediterranean area to Northern Europe. That is, from what I know, the furthest in terms of distance. But again, I've listened with interest to the presentation of Interbulk yesterday. Perhaps those containers might change the picture to some extent. Right now, for us, it's either lorry transportation or ship. Trains don't really play any significant role. That is for continental Europe. I know that it's different in the UK, that we have trains from northern England coming down to the southeast. But those interbulk containers, that might make a change to transportation in terms of rail transportation. But yeah, intermodal, that's something. But as we've heard, and couldn't agree more to what Charles had said, fly ash is very difficult to handle. It has to be in a closed system. Ports are imposing various restrictions on dust flow, so it has to be in a closed system. That makes transshipping even more expensive.
Okay. And you touched very briefly on the possibility of further examination of the properties of conditioned and stockpiled fly ash. Can you tell us a little bit more about that? What are the effects of stockpiling on the properties of fly ash?
The effects of stockpiling, that usually depends if the ash was conditioned with seawater or with river water or fresh water. If it's conditioned with fresh water, there's no reason why it can't be re-dried. Actually, our company is one of the 3 companies in Europe operating a re-drying plant where we put stockpiled fly ash into a gas-fired flash dryer to re-dry to technical dryness. I don't know if that word even makes sense in England. Below 0.03% of water content. It's usable. It's of a very, very consistent quality, as long as it met the requirements of the EN 450 when it was stockpiled. Unless it's contaminated with any foreign particles, there is no reason why it can't be re-dried and used again. Actually, following that lack or that supply problems we had over the past 2 years, we had a huge investigation going in Europe about the use of stockpiled fly ash. Matthias Kuchner was hugely involved in that project, so we looked at Gale Common, Barlow Mountain, other places in continental Europe, if it was feasible to re-dry, to reuse the stockpiled fly ash. It's definitely possible.
Because I would imagine, again, that there must be tens or hundreds of millions of tons of fly ash
Vast
stockpiled
amounts.
throughout
Vast
Europe.
amount of fly ash stockpile, exactly right.
But of course, redrying it, particularly down to the levels of moisture that you've just stated, which seems exceptionally low, there must be quite a cost to doing that.
The cost of redrying it based on today's gas prices with the technology we operate is about 12 euros per ton. That includes depreciation of the facility itself. Having said that, that does not include bringing the ash there and then bringing it to the customer. So it's absolutely borderline economically. For us, it's a strategic thing to do to keep the market happy, because one of the conclusions today definitely is if we don't guarantee reliable supply, then the market will go to competitive products. We will lose the market, and once a big customer is gone to an alternative product, it's very difficult to get him back.
Okay. Any other questions or points from the floor? In which case, Thomas, thank you very much indeed.
Thank you.